All right, here's the next problem, everybody. As always, read the question first. So it says over here, using this measurement, what is the area of the pond? Okay, so again, I'm only going to highlight the most important things. What is the area? And we're describing the pond. So the moment I see the word area, I want to confirm with myself what shape I'm dealing with, because when I can confirm the shape, I can confirm the formula. So here we are. A circular pond is what I see. Let me go ahead and bring it back over here. So a circular pond is designed such that the distance from its center to any point along the edge is 6 meters. I don't know what all that means yet, but I see that it says the area of a circle, so I will write that formula out. Area equals, and I'm going to look at my notes, pi multiplied by the radius squared. So as always, everybody, what does that R stand for? I just said it. R stands for the radius, correct. So what this means, my party people, what that means is, hey, look, my goal is to find the area, so I gotta fill in this formula. And when I check this out, I gotta find out what R is. If I have R in here, great. If I don't, I gotta figure out what R is. I gotta figure out what the radius is. So when I take a look here, it says the circular pond is designed such that the distance from its center to any point on the edge, it's 6 meters. Let me just draw that out. Okay, we have our circle, and it says such that the distance from its center to any point on the edge. Okay, so let me go ahead and start from the center, and let me go to any point on the edge. Everybody, what am I describing here? What am I showing here? Use your eyes. What is that? From the middle to the edge, not all the way across. From the center to the edge, that's radius. Absolutely. Halfway from the center to the edge, that is radius. That is radius, and that is 6 meters. Remember, everybody, area formula for the radius, or area formula for a circle must use the radius. Everybody, which formula is it that can take either the radius or diameter? Which formula is it? Yeah, the formula that goes and uses either radius or diameter, that is going to be, circumference. Circumference, there are two formulas. One is with radius, one is with diameter. The area formula for a circle only uses the radius. And luckily, that's what we're given here. From the center to any point on the edge, that is the radius. Everybody, yes or no, can we confirm that we have the radius, we can plug it in, and we can be done? Perfect. Sounds good. Let's plug it in and keep going. Area equals pi multiplied by, and it says 6 meters. Okay, sounds good. And then we'll square that. 6 squared, which is the same thing as 6 times 6. That is going to be 36. And then we just keep the pi as pi because we look at our answer choices and pi is just pi. Now, pop quiz, everybody. The units here that we see are meters. What is the unit for the area in this problem? Yeah, square meters. Exactly. It's going to be square meters. And there's our answer. Correct answer for this question here is answer choice D. And hopefully we're feeling better and better as time goes on because we're ready for another one. Next problem here. First things first, we're going to read that question. And it says, how many minutes will it have run in total? All right, sounds good. So we want to know the total runtime here in minutes. And to assess the information that we have, it says, well, a machine operates 10 hours per day for 3 days. Sounds good. How many minutes is that? So we're not doing 24 hours times 3, everybody. We're not doing that. Notice that it says that the machine operates for 10 hours a day. Not all 24 hours in a day, but only 10. So on day 1, 10 hours. Day 2, 10 hours. Day 3, 10 hours. Everybody, before we can get to how many total minutes, How many total hours is that? Yeah, 3 groups of 10, that's going to be 30 hours. We have 30 total hours. And so now that we get from that understanding to where we are, now we notice that, look, we want total minutes. We want minutes. That's what our choices say. So we have one more task, and that's converting between hours to minutes. Remember, 1 hour equals 60 minutes. So what we'll do is we will understand that we're going to the unit with the 1. So we will, we're going from the unit with the 1 to the unit with multiple numbers. So we're going to be multiplying. And so because of that, right here, multiply by 60, 30 times 60. All we got to focus on is the 3 times the 6, because that's going to be 18. Then we tack on these 2 zeros, boom, and we have 1800 minutes. And there we are, my party people. That is answer choice C as the correct answer. All right, next question up. So to tackle this question, we're going to begin by understanding that it says, what is her final elevation? So we really want to understand, hey, what's our final position? Elevation is just position, but vertically. We can have an elevation or a depth, but seriously, elevation is just distance, but vertical. So here we go. What we're going to do now is we're going to say that, hey, a climber here starts at 3,200 feet. And then it ascends at this rate and time, and then ascends again at this rate and that time. So, my party people, let me know. When we see the word ascend, every time we see it, what are we doing with those respective distances? What are we doing there? Yeah, we're going to be adding. Absolutely. We're going to be adding. So we start off at 3,200 feet in elevation, then ascending at 500 feet per hour for 6 hours. Well, let's figure out what that is. So a rate of 500 feet per hour times 6 hours, that's going to give us 3,000 feet. And we'll be adding that. And then lastly, we're going to be looking at ascending again, and that's at 400 feet per hour, multiplied by 4 hours. So that'll be 1,600 feet. So once we add all of this back together, we're going to end up getting 32 plus 30. So that's 6,200. And then we add the remaining 1,600 feet at the end. And this makes this a pretty straightforward question, with the final answer being 7,800 feet of elevation is where we end up at. And there we are, everybody. Hopefully this is a good one for you, and hopefully the next one is too.